Hey there, my name is Akshit Madan and I work as a developer relations engineer at Maxim AI. We excel at agent simulation, evaluation, and observability. In this video, my target will be to teach you how to create your first agent using Agent SDK. Not a simple agent, but we are going to integrate Computer Use Agent by OpenAI to kick off a browser session in your local system. Our agent will be a product comparison agent, which is going to take two product names from the user, and it is going to kick off browser sessions to individually scrape data about these products and then present a final README file showing the comparison between the two products. So without wasting more time, let's get started. So first of all, let's see what I have in front of me so that you are familiar with my environment. So I have the documentation by OpenAI open in front of me, and I'm on computer use page. It's just a library that helps you build a computer using agent that can perform tasks on your behalf. And it uses computer use preview model by OpenAI. So make sure that you have enabled it in your OpenAI platform and you have access to it. Then for all the vision capabilities tasks, we are going to use GPT-4o model, and you can also change it as per your use case. And now I have a repository by OpenAI itself where they have provided some great examples to use computer using agent. And over here, if you go to the example section, there are three ways by which OpenAI allows you to use your computer or browser. The browser can be either remote or your local browser. So you can use Scrapybara. So if you check out this weather example, over here this example is using Scrapybara browser. Then we have Playwright with custom functions where they are showing how to use local Playwright. So you must install Playwright in your virtual environment. We'll be doing that very soon. So these are the three ways using which you can allow your LLM to talk to a browser and perform some actions using this computer use agent. For observability and logging, we're going to use Maxim. So we will be seeing how to integrate the Maxim SDK for Agent SDK in this tutorial. Next, I'm going to use Cursor as my IDE and I'm on my terminal. So if I first of all, I need to create a folder for my agent. So let's create it. So my agent has a capability to actually compare two products. So I can say product comparison agent. Let's get inside it. Let's create a virtual environment. Let's activate that environment. Now we need to install the Agent SDK in this virtual environment. So on their official documentation of OpenAI Agent SDK, you can see that this is a command pip install OpenAI agent. So let's just copy it and let's paste it. So Agent SDK is installed. Now you need to install Playwright. Because I had already downloaded it before, that's why I just took the cached one, and I don't have to invest more time on this. But usually this Playwright installation takes a bit of time. Great, so let's just open this folder in my Cursor ID. Now I can start creating the files and start writing the code. So first of all, let's create a .gitignore file and also initialize a git repository. And let's ignore the virtual environment folder, and I'm also going to have .env. Let's ignore the .env file also. Next, what I'm going to have is I'm going to have a file which will be called main.py, and this file is going to contain all my code for this agent. Next, if you come back to your OpenAI CUA sample app, in this you are going to see two folders, agent and computers. Now in these two folders itself, they have actually built the agent for the browser agent, and in the computers file you're going to see the implementation of base Playwright and local Playwright. Yes, you can definitely do it on your own. Basically, these files contain the logic of performing an action based on the response that we have got from the LLM. Let's say the LLM got the image, or the image is just a screenshot of your browser. And in that browser screenshot, LLM detected that there should be a click event on, let's say, this button, some XYZ button. So based on that, LLM is going to return your response with a computer action. And that response can be double click, scroll event, or type event, or wait event, or move event. Right, so all of this logic is there in these files. So we are not going to code them from the scratch because OpenAI has already done this for us very well. So I'm just going to use these two folders in my project so that we don't have to code this again. And these two folders not just contain the Playwright implementation, but they have the implementation behind browser base, and they have the implementation if you want to run your browser in a container. So they have Docker implementation and they have Scrapybara implementation. So that just depends on your requirements and your expertise. But for this video, I'm going to work with local Playwright. So I'll be mostly working with this file. So here I've added my agent folder and the computers folder. And you can see now in my environment, I have the local Playwright and base Playwright implementation also. Now, if you go to your base playwright.py file, it also needs a utils file which actually contains the list of URLs that we want to block. That means on these URLs we don't want to go. And you can modify this list as per your use case and your requirements. So I just dropped the utils.py file also. And as you can see in this file, we just have some block domains and some other code that the sample app must have needed. But for our use case, we are just interested in this block domains list. And you can also see that we have some interesting utilities function also, that like if you want, whenever your agent takes a screenshot of your browser, if you want to show that image to the user, yes, you have that function. If you want to calculate the image dimensions, because you have to pass that image to your model, then there is a function for that. So basically we have all the utility functions in this file, which I don't want to code again because OpenAI has already done this for me. Now I can just go ahead and start writing my agent function, because all the helper functions tasks are already done with the help of the sample app that OpenAI provided to us. So I'm going to import OS. Next, I'm going to import some classes from Pydantic. Let's also import .env, and we need to also install .env. So pip install .env. Great. So this is done, and I don't need this generated code. And yes, we need to load the .environment file. Next, we're going to import some classes from our agent SDK. We need agent, we need run context wrapper. We need runner to finally run our agent. We will need function tool, which will just act as a decorator on top of my tool function. And then we are going to need the response input item, which is called T response input item. Next, we need to import a class from our agent folder. So if you just get inside this agent, and if you go inside this agent.py, this is the implementation of actually handling all the browser actions. Like whether we got a computer action, then it needs to take a screenshot, or it needs to provide that screenshot to our LLM. So this is a agent class, but we cannot import it as an agent class because we have already imported agent from our agent's SDK. So that's why I'm going to call it as from agent dot agent import agent, but let's call it as browser agent. Nice. And from our computers folder, I'm going to import our local playwright class. Import local playwright computer. So all our imports are now written, and now I can start writing the context. So context will be a class. Let's call it as product comparison context, and it is going to inherit a base model. So I'm going to store some variables, let's say product 1. Default value will be an empty string, and we have a description for this. The first product to compare. Then I have second product, and then the comparison results. So let's just click tab. Now instead of comparison results, I'm going to first, so these two are just the product name. Let's say iPhone versus Samsung. Now I need to also store the features of product 1 and product 2 so that we can finally compare them. So product 1 features and product 2 features. And then I'm going to have the final markdown string. This markdown string is going to store the final comparison markdown in a beautiful way. Markdown string to display containing the comparison. Display the comparison. So context is done. Now let's write down the tools. Let's start with defining the decorator. The name of this tool will be online search because we need to take the product name and search about it on the internet. And description of this tool will be use this tool to search the web for information about the product. Let's write down the function async def online search, and it takes a query. Let's say search about iPhone 15. So that's a query over here. And with the query, we also need to provide the context so that we can update that context. Run context wrapper, and this is the context class, product comparison context. Let's start with the try catch block. So from here, the actual implementation of local playwright start. This will be the piece of code which will actually trigger a browser instance and work on your browser. So you can pay attention to this part. So we are going to say with local playwright as computer. So I'm just renaming this object as computer. Let's define the agent. So agent is equal to browser agent, and this is going to take a computer. Now over here, because our computer is a local playwright computer, we have defined it. But if you're using Scapybara or you're using browser base or any of your custom computer, then you can define it over here. Then we are going to define the items, and this items will be empty, and based on the inputs and outputs that we are going to have, these items will be automatically be appended. So let's append this items list with the query from the user. First of all, as you know, that we define the role, and then we define the content. So content is the query. Then we are going to hit the LLM and get the output items. So output items agent dot run full turn, provide the items. Yes, we are in the debug mode, so debug true. Show images. This is actually quite irritating because it actually keeps on showing you the images that the LLM or your browser agent is taking. So I'm going to just disable it, because this is not helpful for me when my agent is running in production. As soon as you get the output items, you are going to again feed it into your items. So items plus is equal to output items. Great. So as soon as there is no other computer action provided or asked by the LLM to perform, then it is going to come out of this block. And as soon as it comes out of that block, we need to return that information that it has gathered of that product. And we also need to update the context of either product 1 or product 2. So if my context dot product 1 is equal to empty, that means if it is still empty, then I'm going to update the context of product 1. Otherwise, I'm going to update the context of product 2. And this will not be query. This will be items at last index at content, and same over here. And this will not be product 1. This will be product 1 features. Product 1 features. And this will be product 2 features. Great. Now we have populated the context class with our product 1 features and product 2 features. And at the end, let's just return the final output of this browser agent. Returns items at last index at content. Finally, let's just write down the exception handling case. This is just going to return the error. That's it. So our tool call is ready, which is going to take a query from a triage agent or any other agent, and it can perform the online search using your local browser. Now it's time that we have to define the agents. So our first agent is going to be called the online search agent, which actually has the access of this tool that we just wrote. Online search agent, and then we need to define the context also. So product comparison context. Define the name of this agent. Let's call it as online search agent. Handoff description. So here is my online search agent, which I've completed. So first of all, I have provided the name, then the handoff description, an agent that searches for product specifications online through browser. And I have hard-coded this line because most of the products that I'm going to provide will be electronic products like phones. So I really like this website where they provide all the basic specifications or some advanced specifications of the phone models. So that's why I provided it a reference that just go on this website and get data from this website itself. So we use GSM Arena website to search for electronic products to get the basic specifications. Then these are the instructions. You will be given a product name that you need to search and web for the product specifications. You need to use online search tool to search the web for the product specifications. You need to return the product specifications in the markdown string, right? Great. And I have defined the model that I want to use. You can also skip this part. And then the tool access. So I have provided this tool access. Now let's write down our triage agent. So here is my triage agent. So first of all, the name, then handoff description, an agent that delegates tasks to the correct sub-agents. Instructions, you are a triage agent. Your goal is to coordinate the process of product comparison. You have to delegate tasks to the online search agent. Receive 2 product names, hand off the first product name, hand off the second product name, return the proper comparison in table form in markdown format string. Now for this small agent that we are building, you actually did not need a triage agent because you only have one agent that is going to work. But we are teaching you this so that you can actually work with some advanced agent also, so that you know what is the purpose of this triage agent, which is actually a kind of a supervisor agent, and it actually decides which agent should work for a particular task. So that's why this is the purpose of showing you this triage agent, so that you already have the information about this type of agents. Now let's just quickly write down the main function, and then we're going to kick off this agent. So async def main, then I'm going to define an instance of my context class. Then for now, I'm going to hard code my 2 product names. But you can feel free to take these names as the input from your user, or let's just do it. Let's just take input from the user itself. Product 1 and then product 2. Then I'm going to update the context, product 1 and product 2. Then I'm going to define the input items, which will be a list of t-response items. Role will be the user. and content will be compare the following products, product 1 and product 2. Then our final result, await runner dot run. We're going to start with the triage agent. So triage agent, input items, and then your final context. Let's just print the final result also. And then finally, whatever is my output, which should ideally be the markdown string, I am going to create a file in my file system itself over here in the folder. And I'm going to save that markdown string in that file. So with open result.md in write mode as f.write result, result.final output. Now let's just call this main function async. We are going to run it in asynchronous mode. So let's just import async IO. So our code is ready. So on a very high level, what we are going to do is we have the main runner, which we have imported from the agent SDK, and it takes the input. So basically our input is compare product 1 with product 2, and these two product names are coming from the user itself, and it directly goes to the triage agent. For now, we just have one agent in the handoff. So triage agent already knows that it needs to give searching of a product name on the internet to online search agent, and in the same way it has to do it for the product 2. And once you get both the informations scraped, then you need to create a beautiful markdown string, and then finally put that markdown string in a new file that it has to create. Great. So it's a very simple agent. We are going to run it, but before that, let's add logging into it, so that even if you are trying to publish this agent to production, you have your traces and logging done in your agent. So we are going to use Maxim for that. So it's very easy. So let's just import Maxim. So from Maxim, import Maxim and config. So we need to install Maxim. So let's just do it. So let's just copy this pip install Maxim Pi, paste it over here and run it. Now from maxim.openai .agents. Maxim has already created an SDK for OpenAI agent SDK. So we are just going to import that itself. Maxim OpenAI agent tracing processor. And at the top itself, we are going to initialize Maxim for observability. Let's create a logger instance. So logger is equal to Maxim, then config API key. So we need to provide the API key, which I'm going to put in my env file. So os.getEnv Maxim API key. And finally, let's say add trace processor, provide the logger. We need to get this add trace processor from agent SDK itself. So let's just import it over here. Done. So we have initialized Maxim. We have created the piece of code for kicking off a new browser instance for your query, so online search query. And we have created our agent using agent SDK. Great. Now let me just write down some env files. First of all, we need to provide the OpenAI key, OpenAI API key. Make sure that you're using the same names. Then I need to provide the Maxim API key. Then I need to provide the Maxim log repository ID. So let's just get on Maxim platform and let's create a log repository. So go on Maxim, go to the logs. Let's create a new repository. Let's call it as product comparison agent. And let's click on create. Yes, we are using Python, setup logger. So continue. Pip install Maxim Pi, we already did it. This we have already done. This we have already done. This also we have done. Instead of doing this, if you just provide your log repository ID in your env file, it will already be done. And I just pasted that log repository ID in my env file. Now I also provide the correct API keys in my environment file, and you can also do that. So that is done. And I think we are just now left with running this agent. And as soon as you run this agent, and over here we missed one thing. We need to say logger because this is a logger, right? Great. So don't forget this. Okay. I think we are all set. And as soon as you run it, you will automatically see that log repository is initialized and it will start showing you the logs. So let's just run our agent now. So let me clear my terminal and say python main.py. So let's put the first product name. Let's say iPhone 15 Pro. Second product name, let's say Samsung S23. Okay, so my browser is kicked off and I can see it searching for Samsung S23 specifications GSM Arena. So let's see how it works. And yeah, I'm not doing anything. Let's see. And yes, it takes some time. because it has to take a screenshot, then screenshot goes to the LLM processes it, comes back with a response. That response can be either textual or it can be some computer action, and then it performs the next action. That action can be like a click, scroll, new tab, just like it did now, or sometimes it also clicks on the ads. So you have to make sure that you're not going on a website where there are so many ads, or the agent get confused with the real content and the advertisements, or you can also block your ads. So let's see if it creates a proper readme of the comparison of specifications between Samsung and Apple. Let's see. Okay, I think it is just trying to scroll now. So it has to scroll and then click on that Samsung S23 block. So let's see. It is taking some screenshots and trying to scroll. Okay, it just scrolled. Now it has to click on that Samsung Galaxy block. Okay, so it just wrapped up the comparison, and as you can see, we have got some of the data back. I found the full specification from Samsung Galaxy S23 on GSM Arena. You can access them by clicking on specifications tab on the page. Okay, so this is just like some output. Updated context, phone model, iPhone 15, Samsung S23. I found a full specification, that is fine. And then we have got these specifications, which it would have gathered from these two pages, and then it has must have like summarized in the form of a markdown. So this is the final result.md file that got created. There are just expected specification may vary based on region and updates. Yeah, that is fine. And if I just see how it looks, so this is a good one, right? This is a good overview of the two model comparisons, like Samsung versus Apple. And this is good to start with, and I hope you will be investing more time on this. And if you come to our Maxim dashboard, you will see that you have started getting the traces. If you go to the logs, we have got the input iPhone 15 Pro versus Samsung S23, 3:46 p.m. So let's just click on it. And over here in the agent workflow, we have the triage agent and we have the online search agent. So first of all, it shows you the agents that you have. If you go inside the triage agent, you see the API calls or the handoffs that are happening. So if I go to the post response, so if I go to the post call, I can see the model that I used, top P, basically all the hyperparameters that I used. I can see the tools information over here, the description and the name. You can see the input from the user, and you can see the system prompt for this agent. Similarly, you can see the system prompt and the tool information about the online search agent. So I hope overall you enjoyed this complete video. So I hope you enjoyed this complete coding tutorial where we integrated Maxim for observability. We created an agent using Agent SDK. We used Playwright under the hood for running your browser instances locally. We used Computer Use Agent to work with Playwright without worrying about the underlying implementations. To get started with Maxim, you can check out the link in the description, or you can directly go on evals.new to integrate observability in your production agents. Till the next video, best of luck for your AI journey.